So my next question is to Bhaskar sir. Sir, as a major as a TP North Odisha Distribution Limited CEO, what kind of mandates are coming with respect to accommodating the new renewable energies sources being created in India?
Yeah, just before I start, I must thank Dheeraj and Elets as well as Pida, and good afternoon to all the audience here. So since morning we are actually hearing about the new and renewable energy sources which are coming up in a big way. Now we have to understand that the entire onus ultimately comes on the transmission and distribution system, because transmission and distribution system are like the blood circulation system of the human body, which carries this power across all the nook and corners, and also it has to be very responsive and sensitive, like the nervous system of the body, so that it can react quickly to the developments. With the advent of this huge load of intermittent power supply which is coming up from all corners, the need of the hour is how can we make this transmission system more and more sensitive, more and more proactively utilizing, and how can we have the calculations for the bandwidth very correctly, so that we can take the additional load without having a significant infrastructure investment to augment the size, to take the entire load. But at the same time, how can we also enable the entire intermittent flow ups and downs to pass through the transmission system? So that is a big challenge, and to add it to that, there are numerous power sourcing options which have opened up, which is earlier we had the conventional long term, medium term, short term power supply, but now we have the GTAM, GTDAM, the IEX, and this the even on the block is the P2P, peer-to-peer trading is also maybe coming up. So all these actually, and the EV, which is a very uncertain, unpredictable, and unassuming, load which will come up. So this actually is something which is a great cause of concern, and we have to apply our minds to make the transmission system equipped to carry this hugely intermittent and fluctuating loads, which was not there earlier, in the transmission system. So to do that, in fact, what we have done in TPNODL and also in the various transmission companies, what we are doing is, first of all, there is a need for data analytics, which is a need of the hour, which actually has to be built in. And so the entire transmission system or our distribution system, we have used software system which is called SIMDIST. It's very popular to map the entire entire transmission system, all the equipments, and also we can do simulation exercises over there, that if the load comes at a certain time of this much quantum, what is the augmented, or what is the optimum size of the transformer, size of the conductors, size of the various equipment which is required to handle the load, and what should be the factor of safety, so that earlier there was a huge difference between what is the transmission available capacity and what is the implemented capacity. The fluctuate the factor of safety was kept as a huge amount, which actually was, now you cannot afford to do that, because if you do that, you have to invest a significant amount on the transmission system. So that much of detailed analysis is being done, that what is the type and quality, and also the the material to be used, which will provide us the same factor of safety apparently, but can use a higher factor, load, and optimize that. So that is the need of the hour. The second thing is, the smartness of the grid is very, very crucial. So we are spending a lot on making the grid smart. Smart metering is installed. Not only smart metering, the entire the value chain of the smart meter, the data will come to the head end system. It will go to the meter, the management system, and the analysis of that is very important. Not only getting the data, that analysis is very important, so that the entire data can be analyzed, and every prediction or every feasibility of any increased load can be immediately taken care of, through the moving out some part of the load from the other sources, or accommodating that. The most important is, how do I accommodate on a very short time scale. Whenever some solar load is increasing, I have to accommodate that through adjustment of the other loads in a different way. So that is very, very challenging as of now. The other is the forecasting, which again was something which was done in a very conventional manner. So now there are forecast requirements, even up to the fact that the weather forecast also have to be a part of the play. Because if you do not do a weather forecast, you do not know how much of generation is going to come tomorrow, or how much of generation is not going to come tomorrow, or what is the area specific generation which is going to come. So the weather forecast based RE generation forecast, which is something which is need of the hour, is something which is being developed in a big way. And the other part is uh, even the life assessment, the import export profile, artificial intelligence, how much of import, how much of export will actually be handled, and that the artificial intelligence has to be built over a period of time, so that this entire import and export of between the grid and the demand of the consumers, as well as the various generation sources, has to be simulated, and has to be coordinated and adjusted. So that's a huge challenge which is coming up on the transmission system. So added to that, there are a few more things which also have to be looked into, whereby earlier the transmission system was on concept of breakdown maintenance. Whenever something breaks down, whenever transformer gets burnt, whenever a conductor snaps, that was being repaired or replaced. But now we have to move to, we cannot afford to do that. We have to move to now we are moving preventive maintenance through engaging of various maintenance gangs on a 24/7. From preventive maintenance, we have moved to condition based maintenance, whereby we are doing the entire scanning of the network through thermoscanning cameras. And through thermoscanning cameras, we get to know the hotspots, and even before they fail, we can do the maintenance, so that they do not have any outages. And from the condition based maintenance, we are moving into a predictive maintenance, where we are using ultrasonic cameras, where the sound, the frequency of the sound which is generated when there is a loose connection or there is a crack in the insulator, that is captured. And from that, you get to know that this has to be replaced. So this is required because earlier you could afford a higher outage time. Now you cannot afford, because it's a very strong push and pull which is happening. Earlier it was almost one way. Now it's a two-way push and pull on the transmission system is happening. So that needs to be done. And also drones are being used in a large way, because many of the transmission lines are passing through forest areas, remote areas, paddy fields, where you do not have access throughout the year. There is either standing crops or there is waterlogged. So we need to do a lot of drone usage. We have mounted those thermoscanning cameras on the drones, and they are going around and taking the pictures and thermoscanning them. So that is again something which we have to be now on our toes, because outage management is again another challenge. And the other is smart integrated operations. Like SCADA was there. SCADA we are implementing, but how can we integrate the SCADA with the GIS, with the consumer relationship management systems, with the SAP, with the maintenance SAP planned maintenance systems, and how can we have an integrated atmosphere that so that not only the grid will be operable, but it can also be visible on the GIS screen, that where is the location, where is the fault, so that the need of the hour is speed and agility. So for that, the entire SCADA arrangement also is being relooked, so that it can give a better distribution management system, and the integration of the SIME list, as I talked about, with the smart metering. Everything has to be now more integrated and more planned manner. And the last point which we are working on is the loss assessment and reduction, because the distribution system actually feeds the entire power sector up to the generation everyone. And the most difficult task is to recover the money from the consumers, the payment from them, and also stop the losses or the theft of energy, which is a major issue which every discom is actually dealing with. So for that, the GIS based consumer indexing and heat maps are being worked out, so that exact pockets where losses are happening, exact pockets where action has to be taken to curb the theft, etc. Energy audit is another important thing which has to be worked out at the distribution transformer level, up to the distribution transformer level, so that you can pinpoint wherever action needs to be taken to do the loss. And the other thing is that we have also started doing that. That's very successful. Is the meter reading, which is a major issue, which is the basis of the entire revenue collection. That was a major issue because it is dependent on the person who goes and takes the meter. There are a lot of issues of connivance with the consumers, a lot of issues of wrong metering, suppressed metering, tabletop metering. So we have introduced OCR, optical character recognition based metering, whereby the actual accurate meter is read, and also wherever smart meter is used, the meter reading directly comes to the back end systems. So these actually are all are aimed to, as I was saying, that how can we make it the transmission system for to graduate not only as a blood circulation system, but as a nervous system. It should be so much sensitive like the nervous system that immediately something happens, we should be equipped to react quickly, so that we can take up the stress which is coming on the system.